All right, so I'm going to do the next 5 on the 2008 non-calculator multiple choice, so 21 through 25. A particle moves along a straight line. The graph of the particle's position is shown above. The graph has horizontal tangents at 1 and 5 and a point of inflection at 2. For what values of t is the velocity of the particle increasing? So they're asking you, where is the acceleration positive? And remember, the relationship goes position, and the derivative of position is velocity, and the derivative of velocity is acceleration, which makes acceleration the second derivative of velocity, of position. So acceleration is the second derivative of position. We're looking at the position graph, so that means that we're going to be looking at the concavity of this graph. The concavity of the position graph tells you the acceleration, because the acceleration is the second derivative, and the second derivative tells us the concavity. So all those things go together. So I'm looking for where the concavity is positive. And so that would be from 0 to 2, where the graph is concave up like a cup. They told me that the point of inflection was at 2, so that's how I know where the concavity changes. So from 0 to 2. All right, 22. A rumor spreads among a population of n people at a rate proportional to the product of the number of people who've heard the rumor and the number of people who have not heard the rumor. If P denotes the number of people who have heard the rumor, which of the following differential equations could be used to model this situation with respect to time where K is a positive constant? So the key to figuring this one out is really that you've got this population of n people. P people have heard the rumor. And the rate that it's spreading is proportional to the product of the number of people who have heard the rumor and the number of people who have not heard the rumor. So P is the number of people who've heard the rumor. There are n total people. So for the number of people who have not heard the rumor, it would be n minus P. And the only one that says that is B. All right, number 23. Which of the following is the solution to the differential equation dy over dx equals x squared over y with the initial condition y of 3 equals negative 2? All right, so differential equation, the first thing you have to do is separate the variables. So I'm going to take this equation and multiply both sides by y dx. Those are my two denominators. So if I multiply this side by dx, I'll cancel out the fraction and separate the variable. And on this side, if I cancel out the y's, I get x squared dx. So I've separated the variables. Then I integrate both sides. So this side, I'm going to get y squared over 2. And on this side, x cubed over 3 plus c. If I multiply through everything by 2, I get y squared equals 2x squared over 3 plus c. And then if I take the square root, I get y equals the square root of 2x squared over 3 plus c. And it's plus or minus. So I can tell that the answer is either D or E. The question is, which one is it? The only difference is, do I have positive in front or negative in front? If I come back up and look at my initial condition, this says when I plug in a positive for x, I get a negative for y. So the answer would have to be E, the one that has the negative in front. That would allow me to get that negative 2. All right, if you plug 3 into that, you will get negative 2. All right, 24. The function f is twice differentiable with f of 2 equals 1, so that's an ordered pair. That's the ordered pair 2, 1. F prime of 2 equals 4, that's the slope at that point. and f prime of 2 equals 3, that tells me that the graph is concave up at that point. What's the value of the approximation of f of 1.9 using the line tangent to the graph of f at 2? So I'm going to write the equation for the tangent line at 2. So I'm going to have y minus 1 equals 4 times x minus 2. And then I'm going to use that to approximate this value. So I'm going to plug 1.9 in for x and see what I get. So I'm going to get 4 times negative 0.1. Whoops, y minus 1 equals negative 0.4. So 0.6. So B. Alright, 25. Let C be the function defined above, where C and D are constants. If f is differentiable at 2, what's the value of C plus D? Differentiable means that when we plug 2 in to both pieces, we get the same thing. That means it's continuous. And when we plug 2 into both the derivatives of both pieces, we get the same thing. That means that it would be differentiable. So when I plug 2 into both pieces, I get 2c plus d. And that has to equal 4 minus 2c. Okay, so that gives me an equation that has both variables, both of c and d. So I'm going to see now what happens if I plug 2 into the derivatives of both pieces. The derivative of the first piece is just c.